Hi everyone, welcome to AI Crack channel. This is Akash Ingwar and today we'll be studying quadratic lecture 1. So we'll be talking about basics of quadratic, identities and nature of roots in this lecture. So let's begin our lecture with the basics of quadratic versus identity. We have studied basics of quadratic in 10th and 11th class, so we'll be just touching upon those once again. So we know that any quadratic equation can be written as ax square plus bx plus c equals to 0. So this is the general format for a quadratic equation. Now we know that quadratic equation has two roots, right? They can be two equal roots, they can be two distinct roots, they can be two complex roots, but it has two roots only, right? Now there can be a case where a quadratic equation has more than two roots. In that case, that quadratic equation becomes an identity, right? So when can we say that a quadratic equation has become an identity? So we can say only when a equals to 0, b equals to 0 and c is also equals to 0. So basically all the coefficients and constant numbers are 0. In that case we can say that the quadratic equation has become an identity. So that means equation can be written as 0x square plus 0x plus 0 equals to 0. So that means everything is 0. So it's just a formal way of writing it. So you might be wondering that what kind of questions can be framed. Now there can be certain statements given like, okay, this is a quadratic equation and it has more than two roots. In that case we have to assume that all the coefficients and constant numbers are equals to 0, right? And we might have to find something out of those conditions. Let's look at one illustration based on same. Find the value of a for which the following equation has more than two roots. So just like I mentioned earlier, it can be given in quadratic form but with a statement that it has more than two roots. So that basically means is it's an identity, right? So considering that this is an identity, so this coefficient is 0, this is also 0 and this is also 0, right? So we have a square minus 5a plus 6 equals to 0. That means a minus 3, a minus 2 equals to 0. That means a is 3 or a equals to 2. We have got these two values. Now if we apply conditions of identity over here, that means a square minus 3a plus 2 equals to 0. That would mean a minus 2, a minus 1 equals to 0, right? So a equals to 1 or a equals to 2. Okay. Now for this constant number, 2a minus a square equals to 0. That means a times 2 minus a equals to 0. That would mean a equals to 0 or a equals to 2. Now we can see that a equals to 2 is common in all three equations, right? So that basically means a equals to 2 should be the answer. Why can't a equals to 3 be answer? Because when we put 3 value over here, it would become 0, but this won't become 0, this won't become 0, this won't become 0. So we have to choose a value of a such that these coefficients and this constant number all become 0 simultaneously, right? That is the value a equals to 2 over here, right? Now let us talk about basics of quadratic equation. So the first one is discriminant. Let's say we have the basic quadratic equation as ax square plus bx plus c equals to 0. So discriminant d is defined as b square minus 4ac. Okay. Now if we talk about the formula, you must be knowing about the formula of roots for quadratic. So that comes out to be alpha comma beta equals to minus b plus minus under root d by 2a. So that basically means if one root alpha equals to minus b plus root d by 2a, the other root beta would be minus b minus root d by 2a, right? So this you all must be knowing from your 10th or 11th class, right? Now, if we talk about relation between coefficients and roots, again, you must be knowing about this from your previous classes, but just let's define it formally once again. So I'm rewriting this equation as x square plus b by a, x plus c by a equals to 0. What I've done is I have divided the entire equation by a. Now, considering that alpha and beta are the roots of this equation, I can also write the quadratic equation in this form: x minus alpha, x minus beta equals to 0. So that would give me x square minus alpha plus beta x plus alpha beta equals to 0, right? Now, you can make a comparison of these two equations. So we can say that b by a equals to minus times alpha plus beta. That basically means alpha plus beta, that is summation of roots, is minus b by a. And similarly, Product of roots is c by a. So these are the two relations you should be knowing. Now let us solve this question. Find k in the equation 5x square minus kx plus 1 equals to 0 such that the difference between roots of the equation is unity. And the most important phrase over here is difference between roots is unity, right? So what do we mean by that? Let's say this equation has roots alpha and beta, right? So that means alpha minus beta equals to 1 or beta minus alpha equals to 1. You cannot say if it is alpha minus beta or beta minus alpha. It can be any of these, right? So that means modulus of alpha minus beta is 1. Okay, we can simply say that. Now let's write the other equations as well. We have alpha plus beta equals to k by 5 by minus b by a, right? And alpha beta equals to c by a, that is 1 by 5 over here. Now we have to employ all these three equations over here to find out the value of k. So let's try to find out relation between alpha plus beta and alpha minus beta, right? So we know that alpha plus beta whole square equals to alpha square plus beta square plus 2 alpha beta, right? And if I subtract minus 4 alpha beta on both sides, right? Alpha plus beta whole square minus 4 alpha beta equals to alpha square plus beta square minus 2 alpha beta, right? Because we have subtracted 4 alpha beta from here. Okay. Now this becomes alpha plus beta whole square becomes k square by 25. Now 4 alpha beta becomes 4 by 5, or you can say 20 by 25, right? And this becomes alpha minus beta whole square, that is nothing but 1. Okay. Now you can simply cross multiply over here. So this becomes k square minus 20 equals to 25. So this becomes k square equals to 45. K equals to plus minus root 45. Okay. Now let's solve this question. If alpha is not equals to beta, but alpha square equals to 5 alpha minus 3, beta square equals to 5 beta minus 3, then the equation whose roots are alpha by beta and beta by alpha is. Okay. Now the given conditions are alpha square minus 5 alpha plus 3 equals to 0, beta square minus 5 beta plus 3 equals to 0, right? Now we can simply say that alpha and beta are the roots of x square minus 5x plus 3. Right? We can simply say that based on these conditions. Now we have to find out the equation whose roots are alpha by beta and beta by alpha. So the basic format of the equation would be x minus alpha by beta multiplied by x minus beta by alpha equals to 0. This would be the basic format. That means it would become x square minus alpha by beta plus beta by alpha x plus product of these, that would be 1, equals to 0. So we have to find out the value of this one to find out the equation whose roots are alpha by beta and beta by alpha, right? Now based on this, we know that alpha plus beta equals to 5 and alpha beta equals to 3, right? So if we want to write this one, alpha by beta plus beta by alpha, that would be alpha square plus beta square divided by alpha beta, right? Now alpha square plus beta square is nothing but alpha plus beta whole square minus 2 alpha beta divided by alpha beta. Now alpha plus beta is 25, alpha plus beta whole square is 25, minus 2 alpha beta is 6, divided by alpha beta is 3. So this comes out to be 19 by 3. So what we have got over here, x square minus 19 by 3 x plus 1. Let's take the LCM. We'll be getting 3x square minus 19x plus 3 equals to 0. So this is the final equation, right? Now let's talk about nature of roots, and we have three cases over here: d greater than 0, d less than 0, and d equals to 0. In the first case, where discriminant is greater than 0, we have two real and distinct roots. Okay. Now in the second case, we have two complex roots. In third case, we have two real roots which are same, basically equal. We have two real roots which are equal. In this case, ideally we can say that, okay, we have just one root, but technically we can say we have two real roots which are equal. In this case, we have two real roots which are distinct. In this case, we have two complex roots. So in these two cases, the first one and the third one, we have real roots. Okay. Now let us move forward with this question. Let PQ belongs to 1, 2, 3, 4. The number of equations of the form px square plus qx plus 1 equals to 0 having real roots is. Now in this case, the main thing over here is having real roots. Now in case of real roots, d can be greater than 0 or d equals to 0. Both cases are possible, right? So technically, discriminant should be greater than equals to 0, right? So discriminant over here would be q square minus 4p, right? Now this has to be greater than equals to 0. So we have to take cases over here. The first case would be p equals to 1. Now when p equals to 1, that means q square minus 4 should be greater than equals to 0, right? So that would happen when q is either 2, 3 or 4. We have three cases. In all these three cases, q square minus 4 should be greater than equals to 0, right? Now let's take p equals to 2. In this case, q square minus 8 should be greater than 0, greater than equals to 0, right? That means q would take 3 and 4, these two values. In case p equals to 3, we have q square minus 12 greater than equals to 0. That means q will take only one value, that is 4. Now p equals to 4, q square minus 16 greater than equals to 0. That means q will again take the value 4, because in case of 4 we have the equality. We don't have to forget the equality part, right? So we have 7 cases over here, 7 possible values, 7 possible pairs of p and q for this particular condition. Px square plus qx plus 1 having real roots. Okay. Now let's talk about nature of roots in more detail. So earlier in previous slides, what we did, we defined one case d greater than 0, and we concluded that in this case, roots are going to be distinct and real, right? Now let's further subdivide this case into two parts. The first part is d is not a perfect square, and then what would happen? And the other case would obviously be d is a perfect square, and then what would happen? Right? Let's take one example. X square plus 4x plus 2 equals to 0. In this case, d is 16 minus 8, and that is not a perfect square, right? This is not a perfect square. So the first root would be minus 4 plus root 8 divided by 2, and second root beta would be minus 4 minus root 8 divided by 2. Now you can see that minus 4 and 2 over here is common, but we have a plus root 8 and minus root 8 over here. So what can we conclude from this? We are getting roots as conjugate pair of surds, right? So let's say there's one more question, and we have been given root alpha 1, first root given as 5 plus root 6 by 3. Now in this case, we can predict the second root as 5 minus root 6 by 3, because that would happen only in these kind of cases where d is not a perfect square. When d is not a perfect square and one root is real, the other root would be a pair of this one with a negative sign in front of irrational number, right? Now the second case is d is a perfect square. Now in this case, let's take one more example. X square plus 4x plus 3 equals to 0. Now discriminant would be 16 minus 12, that is 4. Now in this case, alpha, the first root would be minus 4 plus under root 4, that is 2 only, divide by 2. Second root beta, that would be minus 4 minus 2 divided by 2. Now you can see the difference over here. So we have minus 1 as this root, and we have minus 3 as this root. Now if there is one question where one root is given as 1, or let's say 2, we cannot tell the other root. We can never tell what the other root is going to be unless there is some more conditions given, right? In case of when d is not a perfect square, in that case we can tell by just looking at one single root, we can tell what is the other root. But in case when d is perfect square, we cannot do such kind of things. Okay, so we have case 3 where abc are real and d is less than 0. So this is the different case. So we have, let's say, x square plus 4x plus 5 equals to 0. Now in this case, d comes out to be 16 minus 20, that is minus 4. Now the first root would be minus 4 plus under root minus 4 divided by 2, and second root would be minus 4 minus under root minus 4 divided by 2. Now again you can see plus sign and minus sign over here. We have pairs, but we have pairs of complex numbers. We have complex conjugate pairs over here. So again, in this case, if one complex root is given, we can predict the other root with the help of that one, because these roots occur in pairs. Okay. Now let us solve this question. If alpha and beta are two distinct real roots of x square plus px plus q equals to 0, and alpha 4 beta 4 are the roots of x square minus rx plus s equals to 0, then the equation x square minus 4qx plus 2q square minus r equals to 0 has always two distinct roots, two positive, two negative, one positive, one negative root. So considering these options, the first option basically, we understand that the first thing we have to do is we have to find out the discriminant over here. Discriminant of this equation. Okay. So d would come out to be 16q square minus 4 times 2q square minus r. Now that would become 8q square plus 4r. Now in this case, 8q square is quite obvious that this is greater than equals to 0, right? Because it's q square, it's always going to be positive or 0. But we don't have a clue for 4r as of now, right? So for r, we have to refer this x square minus rx plus s. So what is the value of r over here? That is minus b by a. Minus b by a is nothing but summation of roots. So alpha 4 plus beta 4 equals to r. Now, although these two are even powers, we still cannot say for sure that this is always going to be positive. It might be 0, right? So we're not still sure that this is going to be greater than equals to 0 or just greater than 0, right? We're not sure. So again, for that, we have to refer to the first statement. This one, alpha and beta are two distinct real roots. Now, in case alpha or beta, one of the roots is 0, the other root cannot be 0. It can be a positive value, it can be negative value, because we have two distinct real roots. So if one is 0, the other one cannot be 0. It can be positive or negative. Now, this property would reflect over here as well, because we have alpha 4 and beta 4 as the roots of this equation. So if one is 0, the other one is definitely going to be positive because of this even power, right? Regardless if beta is negative or positive, beta 4 is going to be positive always, considering that alpha is 0, right? So that means this term is always going to be positive, not 0. It can never be 0, right? Because we have two distinct real roots over here. Okay, so r is always positive. So considering that, 8q square plus 4r will always be positive, right? Because of 4r, this term would always be positive. And when this is happening, you can say that A option is correct. Two distinct real roots, right? Now coming to the second part of this question, they have basically hinted to find out the signs of the roots, positive roots, negative roots, or positive or negative roots, right? For that, the best way to do this to find out the product, to find out the sign of the product of roots. So for this equation, so 2q square minus r is the product of roots. But again, we can say that we know something about this, we know something about this, but we don't know the relation between them together. We cannot say for sure 2q square minus r is positive or negative. We cannot say for sure, right? Because unless there's a positive sign over here, we cannot say for sure, because we have a negative sign over here and we have to find out the relation between them to make a conclusion. Okay. Now, once we have done that, we have to find out the relation between them. So 2q square, 2q square comes from here. Basically, q square comes from here. So q equals to alpha beta, product of these two roots, right? And r is nothing but r is alpha 4 plus beta 4, as we have seen from this equation, right? So we'll plug these values in this equation and see what happens. So this becomes 2 alpha square beta square minus r is alpha 4 plus beta 4, right? So what I'll do, I'll take minuses common from the entire equation, and it becomes 2 minus 2 alpha square beta square plus alpha 4 plus beta 4. Now this, if you look at it carefully, this becomes alpha square plus beta square whole square. And this is always going to be positive. Why? Because again, we have alpha and beta, two distinct numbers, two distinct real roots. So if one is 0, other one cannot be 0. And the whole square of that would always be positive. So with a negative sign, this entire 2q square minus r would always going to be negative, right? And if this is negative, that can only happen is when one root is positive and one root is negative. One root is positive and one root is negative. So D is the correct answer, right? So this was one of the most toughest question you can get in PGDBA in terms of quadratic equations. And mostly you will get something below that, below this kind of difficulty, right? So let's meet in the next lecture to study more about quadratic equations, and thanks for watching.